Textron Aviation has adopted Garmin integrated avionics suites for most of its new production airplanes, but surprisingly, one of its most popular and long-produced airplanes, the Citation XL XLS, still comes off the assembly line without the Garmin treatment. But with about 700 of these models already flying, Garmin saw an opportunity to offer a retrofit, and XL owners can now replace their original Honeywell avionics with a fully modern G5000 flight deck. The Garmin Supplemental Type Certificate for the XL XLS not only gives owners and operators a fresh flight deck with 3 14-inch displays, but also 2 touchscreen controllers, a GWX-75 digital radar, and an autopilot. Options include synthetic vision, surface watch runway monitoring, underspeed protection with coupled go-around capability, and Flightstream 510 wireless gateway. Garmin invited me to fly its G5000 equipped XLS, and we set up a short trip that would give me a good taste of its capabilities. We flew from New Century Air Center in Olathe, Kansas, where Garmin has a flight test facility, to Ponca City in Oklahoma. I climbed into the left seat next to Garmin test pilot Scott Wheeler, and he plugged in our flight plan to Ponca City via Wichita, requiring just a few taps on the touchscreen. And it was a short taxi to runway 18. Once lined up, I pushed the power levers to takeoff power, and the 3,975-pound thrust Pratt PW 545Bs spooled up quickly and launched us down the runway. As is normal for the XLS, I had to pull back fairly briskly on the yoke to rotate the nose, then back off a little to avoid pitching up too steeply.
Oh yeah, different pitch. You can feel it.
Positive.
Okay, gear up. And flaps when you're ready.
Roger.
I pulled the power back soon after retracting the landing gear and flaps. Then with the autopilot on, we climbed to flight level 200 for the short flight to Ponca City, using flight level change mode to set the climb speed to 220 knots. While en route, Wheeler sent a sign-on message via controller pilot data link communications to Kansas City Center, letting the controllers know that we were able to communicate via CPDLC. This was my first time seeing a live in-flight CPDLC Datacom exchange. Although it does share some characteristics with text messaging, FAA Datacom, the official term for en route CPDLC, isn't quite the same. Unlike text messaging with a smartphone, CPDLC uses canned messages, and although free texting can be done, it's discouraged to avoid confusion. The best part of CPDLC is that complex messages like route changes can be loaded straight into the avionics. Of course, pilots need to double-check that the correct information is loaded before accepting the altered flight plan, but it saves a lot of the writing and button pushing that is typical with radio voice communications. During our flight, once we acknowledged the frequency change, a new message popped up, asking which radio we wanted to tune with the new frequency. Wheeler selected COM1 active, and the new frequency automatically went to the correct COM1 field, moving the current frequency into the standby field. This was much simpler than typing in the new frequency and helps eliminate keystroke error. It also reduces the amount of voice radio traffic. The XLS G5000 avionics suite has all the latest Garmin bells and whistles, such as heading sync mode, which keeps the heading synchronized when turning on autopilot, and in nav mode. I like the horizontal situation indicator map, which is like a mini multifunction display, and HSI, with lots of overlays available. We planned a straight-in ILS approach to runway 17 at Ponca City. Wheeler showed me how to split the screen on the primary flight display, then pull up the approach chart on the left third next to the 2/3 primary display elements. The 14-inch display is large enough to see the entire approach chart. We also placed the vertical situation display on the bottom of the multifunction display's moving map. Wheeler plugged in the landing information, and the Garmin Avionics calculated the actual landing distance as 3,144 feet. leaving us plenty of margin on the 7,201-foot runway. Our approach speed was 121 knots, while the landing reference speed was 114 knots. After being cleared to descend to 3,000 feet, our magenta jet symbol crept onto the top of the approach blade on my screen, and I slowed below 200 knots so we could begin deploying flaps, then the landing gear as the glide slope indicator showed one dot above the center. It was hazy and warm, and the gusty wind was nearly straight down the runway, which was easily visible as we trundled down the glide path. The autopilot flew perfectly smoothly while I adjusted the power levers to set the speed, and at about 400 feet above ground, I switched off the autopilot and yaw damper. Keeping the G5000's flight path marker on the synthetic vision display aimed at the touchdown zone, I eased the power back and pulled the nose up just a tiny bit, and the XLS touched down relatively smoothly, aided by the trailing link landing gear. The G5000 upgrade adds many modern capabilities to the XLS. At about $475,000 to $525,000, this is a significant upgrade, and installation at a Garmin dealer takes about 1,500 to 2,000 hours of labor. Buyers can also get the G5000 upgrade through the Citation Partners XL Eagle refurbishment program. For an airframe and engine package designed to last for decades, an STC like the G5000 upgrade adds a lot of utility and value.